Hello students, today we are going to start exercise 4.3 from same lesson quadratic equations, right? And our first question is, okay, here is written, find the nature of the roots of the following quadratic equation. If the real roots exist, find them. Okay students, here we need to find the nature of roots, right? And nature of roots means simply types of values of variable that we obtain after solving the quadratic equation, right? And here we can use discriminant formula for finding nature of roots. But what is discriminant? Regarding this, I have already told you in previous video, right? Anyway, let me remind, discriminant is that which helps us to identify whether a quadratic equation has two distinct real roots, two equal real roots, or no real roots without actually solving the equation, right? And for finding discriminant, we have this formula. By using this formula, firstly, we will find the discriminant, and according to discriminant thus obtained, we can easily determine the nature of roots, right? Suppose if discriminant is equal to 0, then there will be two equal real roots, right? Similarly, if discriminant is greater than 0, then there will be two distinct real roots. Distinct real roots means two different real roots, right? Similarly, if discriminant is less than 0, then there will be no real roots. In this way, with the help of discriminant, we can identify the nature of roots, right? Okay, now let's back to the given question. Our first question is 2x square minus 3x plus 5 equal to 0. In this equation, a equal to coefficient of x square, that is 2. A equal to 2. Similarly, b equal to coefficient of x, that is minus 3. b equal to minus 3. Similarly, c equal to constant part, that is 5. c equal to 5. Now, for discriminant, we have formula d equal to b square minus 4ac. Now, b equal to, we have minus 3 square minus 4 into a equal to, we have 2 into c equal to, we have 5. Now, square of minus 3 will be plus 9 minus, and here 4 2 ja 8, 8 5 ja 40 minus 40. Then after subtracting, we will obtain discriminant, that is minus 31. And as we know, here discriminant is less than 0, and in this condition, here is written, if discriminant is less than 0, then there will be no real roots, right? Now question number 2, which I have already copied here, and in this equation a equal to plus 3 and b equal to minus 4 root over 3, minus 4 root over 3 and c equal to plus 4. Now we have a formula for finding discriminant d equal to b square minus 4ac. Now b equal to we have minus 4 root over 3 minus 4 root over 3 whole square minus 4 into a equal to we have 3 into c equal to we have 4. Now here firstly square of minus 4 will be plus 16 and this square and this sign of root will be cancelled and here remains only 3 and 16 into 3 we obtain 48 minus and here also 4 3s are 12 4s are 48 and 48 minus 48 finally we obtain discriminant equal to 0. Here discriminant is equal to 0 and in this condition as we know if discriminant is equal to 0 then there will be two equal real roots, right? Now we have to find those two equal real roots by using quadratic formula and our quadratic formula is x equal to minus b plus minus root over d by 2a. Now x equal to minus b equal to we have minus 4 root over 3 minus 4 root over 3 plus minus root over d equal to we have obtained here 0 by 2 into a equal to we have 3. Now x equal to here minus into minus plus, so 4 root over 3 and here root over 0, so no need to write this, by 2 into 3 6. Now 2 2 ja 4 2 3 ja 6, so x equal to here 2 root over 3 by 3. Now to cancel this root over 3 from numerator we can write this 3 in the form of let's do here 2 root over 3. Now this 3 can be written as root over 3 into root over 3 because when we multiply this root over 3 and root over 3 finally we will obtain same number, that is 3. Let's multiply over here. We have root over 3 into root over 3, then it can be written as root over 3 whole square and this square and this sign of root can be cancelled out and here remains only 3, right? So we can write 3 in the form of root over 3 into root over 3. Now 1 root over 3 and this root over 3 can be cancelled out and here remains only 2 by root over 3. So it is the value of x, and another value will be same, 2 by root over 3, because here discriminant is equal to 0, and as we know, in that condition there will be two equal real roots that we have obtained over here. This is our final answer. Okay, now question number 3, which I have already copied here, and in this equation a equal to 2 and b equal to -6, c equal to 3. Now we have a formula for finding discriminant. That formula is d equal to b square minus 4ac. Now just put the value. B equal to, we have -6 whole square minus 4 into a equal to, we have 2 into, and c equal to, we have 3. Now square of -6 will be 36 minus 4 to the 8 and 8 3 the 24. After subtracting, we obtain discriminant is 12, which is greater than 0, and as we know, in this condition there will be two distinct real roots, right? Now we have to find these two distinct real roots by using quadratic formula, right? And our quadratic formula is x equal to minus b plus minus root over d by 2a. Now just put the value. B equal to, we have -6, so minus b equal to -6 plus minus, and d equal to, we have obtained 12 by 2 into a equal to, we have 2. Okay, now let's proceed to next page. Okay, here minus into minus plus, so plus 6 plus minus root over, and this 12 can be written as its factors like this: 2 into 2 4, and 4 into 3 12 by 2 into 2. Again 6 plus minus, and here this 2 has pair, so 2 can be taken out. 2 root over 3, 2 into 2. Again from here 2 is common, so here remains 2 3 the 6 plus minus, and here remains 1, no need to write, root over 3 by 2 into 2. Now these 2 and these 2 can be cancelled out, and here remains 3 plus minus root over 3 by 2. And here, as we know, if there is sign of root over any number, then that number possesses both sign plus and minus, right? It means this root over 3 possesses both sign plus and minus. So this expression can be written by two ways, by using sign of addition and sign of subtraction separately, right? And this will be our answer. So it can be written like this: x equal to 3 plus root over 3 by 2, again 3 minus root over 3 by 2. This is our final answer.